Our next example says, in a research experiment, a population of fruit flies is increasing according to the law of exponential growth. Well, the law of exponential growth is y equals ae to the bx power. And it says after 2 days there are 125 flies, and after 4 days there are 350 flies. How many flies will there be after 6 days? So for us to know how many flies there will be after 6 days, we need to first of all find the growth rate. And for us to find that growth rate, we're going to have to solve this equation for B. So we know that at 2 days there's 125 flies. So A is the amount that we start with initially, so that's 125 flies. I don't know what B is, that's what I'm trying to find. But I know that if 2 days pass, I'm now on the 4th day, and on that day there are 350 flies. So I now have an exponential equation. So to solve, I'm going to first of all divide by 125, and I'll get 2.8 is e to the 2b. This is an exponential equation that involves e. So to solve, we're going to take the natural log of both sides. And we've learned that using the inverse property, the natural log of e to a power is just the power. So b turns out to be the natural log of 2.8 divided by 2. So b is approximately equal to 0.5148. So now that I know b, I'm going to go back and I want to answer the original question. And that original question was, how many flies are there at 6 days? So I'm going to start with my exponential growth formula again, y equals ae to the bx. And I know that at 2 days I had 125 flies. I now know that b is approximately 0.5148. And when I actually solve this equation on my calculator, I really don't round it off to 0.5148. I really use the natural log of 2.8 divided by 2 so that I will get a better answer. And then I'm going to let x be 4, because if 125 is at 2 days and I want to know what happens at 6 days, that will be 4 days later. So I enter this on my calculator and I get 980 flies.